Hey fam, welcome back. And today let's solve symmetric tree. So yeah, again the question is pretty straightforward. You'll be given the root of a binary tree, and you have to check whether it is a mirror of itself. And if you know how mirror works, then everything will be reversed. So yeah, see over here 2 2 and 3 4 should become 4 3. So yeah, this is true. Yeah, I'll just give you a second to go through the example. And now look at this example. Even though the nodes are 2 3 2 3, when you take this part and reverse it, it won't become this part. Yeah, again you have to have imagination to know why, to know how to write an algorithm for this, because first you have to come up with an algorithm, and to do that you have to first understand the question. So yeah, again whenever you see this question, only one thing should pop into your head. I'll give you a few seconds to think about it. Yeah, I want to tell that there is a recursive way to do it also, but recursion is lame, man. Come on, iteration is the best. And yeah, and whenever you think of iterative and you see this question, only one thing should pop into your head. Yes, again, it's level order traversal. It's the boogeyman. And if you have watched John Wick, then yeah, it's the Baba Yaga. And so how it works? Again, you have to go level by level, and just if there is only one node, that means it is obviously the root. So you have to return. You have to continue to the next iteration, and when you have to, and when you have an array filled with two numbers, then you have to check for the middle point. Take the left half, take the right half, reverse the right half, and check for equality. Yeah, it is that simple. Yeah, again, write this part with your eyes closed. If you can't write it, then learn level order traversal. It's very important. Then yeah, again be sure to add character clauses and all, because if there is no root, then the code will obviously fail. So yeah, if not, then re, yeah, English is very hard. Tu okay, return true, because an empty tree is always a mirror image, or else you will put elements in the queue, and queue exists, have a temporary to store all the values in the current level. And I think you know why I am not using I over here, but I'm using the underscore operator. This is mainly to make sure that if by chance I use I anywhere further down the line, then that should not affect my code, mainly because yeah, this value is not at all being used anywhere. This is just to check for the length of the queue. What you have to do, pop out the node, and in classic level order traversal, what you did, if node dot left exists, then, and if node dot right exists, then yeah, this is how we proceeded with classic level order traversal. But yeah, there is one thing which you should be careful of, and if there is no node, then you okay, consider this level and consider the 1 2 3 level 3. So when you look at the tree and the level, the actual level is null, and then you have a 3, and then you have a null, and then you have a 3. But when you do like this, what will happen is you will just have the values 3 comma 3, and when you check for the middle point in this, you will get it to be this index, and yeah, the left half will become equal to right half, and you will return true, and that's not what you want. So what you have to do, whenever you check for a node, and if there is no node, what you do, to the temporary array you append the value none. And for these checks, don't check for the node dot left and node dot right, just check for node. Just check for node over here. And yeah, with very minor modifications to our code, we can directly come up with the algorithm for this. Yeah, then if not node, then yeah, if there's no node, then temp dot append none. After appending none, what you have to do, you have to continue, because since there's no node, there's no need to check for this stuff and all. And yeah, let me just print out our temp array once. And yeah, can you spot out the error? Why is everything none? It's pretty obvious because I'm not appending the value of the current node. It's node.12. And yeah, this is checking for the final level. Let's look for this example. Yes, and now you see over here, forget the final level, it does not matter for us because everything after this nodes are null. But consider the third level. You see that it is none, 3, 3 and none. Now you can obviously break this array in the middle and check this part after reversing it, and you will have your answer. I hope you understood why and how it will work. And yes, let me just proceed with the code. If length of temp is equal to 1, that means that there is nothing to check, then you have to continue. And if it is not equal to 1, then what you have to do is you have to calculate the midpoint divided by 2. Yes, and then left half, what will be the left half? It will be the value of temp from everything till the middle, and the value of right half will be the value of everything of temp from mid to end plus 1, mid to end or length of the array plus 1. And yes, but what you have to do, you have to check for mirror image, and to check for mirror image you have to reverse the right half itself. Yes, you consider this itself. Yeah, now actually none and 3 and 3 and none, you have to check for its mirror image. So after breaking this part and this part, you have to reverse it and check it. So I hope you understood why it works. So if equal to right half, then yeah, it is obviously not a mirror image, so return, or else. Yes, and this should work theoretically, and yes, it works. And I hope you knew why it works. And yeah, okay, now consider this test case. Let me print out our temp array once, and I'll show you the third level. And let's look at the third level. It is 3 none and 3 none, which is actually equal, but you should reverse this because whatever you see in mirror will be reversed. Yeah, I hope you know why it will be reversed. I don't want to go into physics and all because this is mainly computer science based subject. And now let's just submit it, and be sure to remove all your print statements. And here it works, but yeah, it is now not that efficient, or it might be efficient, might be my network is slow. Let me just submit it once more. Okay, it's not that efficient, but here it works, and any solution is better than no solution. So yes, thank you. Grind DSM more.